So, welcome to lecture series on data structures. So, in today's data structure, we will see about linked list ADT. So, let's go straight into the topic. So, just look at the picture once for now. So, when we discuss about what linked list is about, at that time you will understand what this picture is trying to convey. So, this is obviously a train with various compartments, and all these compartments are linked together. So this much understanding is enough for now. Same thing. So each compartment will consist of passengers. So let us consider these passengers as data. So the link is the connection between two compartments. So let us assume this compartment as node. So the connection is the pointer, which one compartment is linked to other compartment in the sense this connection points to the next compartment which it is pointing to, right? So this connection can be considered as pointer. So same thing is applied for linked list. So this entire thing is called as linked list. So it consists of various nodes. Here the compartment represents the nodes. So this node is used for storing the data. So here the data is a passenger which is present inside the compartment. So all these nodes are linked together with the help of pointers. So that the link chain between the compartment represents the connection. So here is the definition of linked list. So linked list is a special type of data structure where all the data elements are linked to one another. It is also considered a collection of nodes where every node will consist of two fields. One is the data field and another one is the address field or the pointer field. So the data field will hold the data and the address field will hold the address of the next node it is pointing to in the list. So this is a pictorial representation of linked list. So as I said before, each node consists of two fields. One is the data field and other one is the pointer field. So let us assume the memory address for each nodes. And for the first node it is 1000, second node it is 2000, and third node it is 3000. So here the first field the value 10 represents the data. So what I said, the next field will hold the address of the next node in the list. So here, what is the first node pointing to? It is pointing to the node 2. So what is the address of node 2? It is 2000. So by any means, the address 2000 will be stored in the address field or the address part of the node 1. Similarly, the address of the node 3, which is 3000, will be stored in the address field of node 2. So here is one example to have a better understanding of why we used linked list. So the problem discussed here is sometimes you may need to store more than 50 student marks. In that case, you cannot increase the memory of array. As I have declared the size of array as 50. You look at the example, it is declared as int marks of 50, which means I can store only 50 marks, right, in that particular array. So if I want to store more than 50 marks, or if I want to store only a few marks, if I want to store less than 50 marks, in that case, extra memory will be wasted. In the previous case, you may require extra memory, which is not possible, which is hardly possible, right? So the strategy used here is to overcome this problem, we will use linked list, because in linked list, memory can be created at runtime. It is much easier when compared to array. So the limitations, however, it has its own limitation. The limitations are it needs more memory. For stored data in linked list, you need more memory space, and you need memory space for both data field as well as for address field or pointer field. So this linked list has three types. One is singly linked list, other one is doubly linked list, and third one is circular linked list. So singly linked list, it has one data field and one pointer or address field. Doubly linked list has one data field and two address or pointer fields. And circular linked list is a singly linked list where first node and last node will be linked together.